Hey, hi all. Hope you all are doing well. Welcome to Azure Space. So I'm creating this current video. This is regarding creation of data frames using PySpark. So currently I'm using Databricks as a tool to work on this. You can feel free to do this in your local or even in Azure Synapse Analytics. You just need to make sure that you have an active Spark session with you. So Databricks gives me that capability that it inbuilds create a Spark session for me whenever I spin up a cluster. So I'm using that. But internally, all the logic and all the layout of the code will remain same wherever you try that. So let's get started in this. So I'm currently using a Databricks community version to work on this. And I have spin up a cluster as of now with this name in the community version. And I will make sure I'm connected to that cluster in this notebook. Okay. Now, before getting started with anything, I just wanted to let you know, give you a brief about data frames. So data frames, you can relate it to the SQL tables, which is a group of rows and columns to store data. So it is a two-dimensional model to store in data. Now, you can think that let's say that we want to create a data frame which looks something like this. I have an ID column and a name column. So I want to implement this in a code manner and it should create a data frame for me. So what I can go ahead and do is that let's try to break this down into smaller pieces. So let's say this is the first row, second and third. Let's take in the first row itself. So if you see, this is two values. One is the ID and the name. So in Python, we have various ways to store in data, a group of data. There are various options, which can be list, tuples, dictionary, even sets. So let's start with any one of them to store my data, a line of data in with me. So let's say I create a tuple first of all. In order to create a tuple in data Python, we use this bracket. Now, what is my data in the first row? I will just populate the same in here. So it's 101 and the name. So I will say 101. I can keep 101 as a string and the name as in like this, 101 as an integer and the name as in string. So this becomes a single record. So within that, I have multiple two records in this. Let's say if I want to print this, this comes as these two values. Now, this becomes my first row itself. I can give this to my data frame. But data frame always accepts a list within which it iterates over. So everything, whenever data frame, the Spark data frame, the function that we will use, that is Spark, that session that is created automatically. Within that, we have a session method called data frame. And this data frame accepts an argument called data. And this data argument only accepts a type of a list. So within that list, it needs to iterate over the data. So we need to make sure whatever data we are passing, we are enclosing it within a square bracket. So that makes sure that it converts it into a list. So let's say I rerun this and I pass my tuple in here, data equal to tuple, and I run this. Yeah, so it created a data frame with two columns. It might be odd because if you see, we haven't specified anywhere the name of the column. So it took some random value, not random, but it assigned some values to it. The first is the _1, second is _2. Now, if I want to display it, I can just simply say dot display. So it will show me how the data is looking inside the data. So I got the first value. So my first row is made something like this. So I was able to achieve this part. Now let's say I want to add in the second row as well. So what I can do is that within this list, I can just give a comma here and I can add in another record. So I will just copy this, change the value, change the name. Let's say change it to this. I rerun this and I again pass it to the data frame. This time around, it created with two values. So now few things are left. The column name, we are not able to specify in here. We'll see how to specify. But before jumping over that, there are other types of data storage elements in Python. The second of which is a list. So list is nothing but a square bracket value. So I can pass whatever value I had in the tuple inside this. So this will become a list. I can even pass the second value. Let's say give a comma and this. This becomes 102 and this value. Now, as you know, the data frame always accepts the list. So I have to enclose this also within a list. So this becomes a list of a list. So I just say print this lst, and I again use the same code to create the data frame. So this time around, I will point the data equal to a list. So this also works similarly. Just the data where I stored elementary data, that got changed. Earlier it was a tuple, now I am storing it into a list. Another way to create a data frame in data Python or PySpark more to be specific is a dictionary. And dictionary is a key and a value pair. So every time you have to specify, first of all, the key, then the value of it. So I had these two values, correct? So this is the first. Let's give it the name to the key like ID. And this value, give it the key name as name. So I will give a comma in here. I will say this is the second one, which is name, and I'm passing the value in here. So this becomes one record of a dictionary. Now let's say I want to populate another, like I was doing in list and tuple. So I will just say comma, I will give this, and I again need to enclose everything within a square bracket. Let's say I do a print now. So this becomes a dictionary of a list of a dictionary. Let's say I pass this to my data frame, and within the data, I will pass the dictionary now. This time around, if you see, a change happened. This time it took the key values as the column names. So now I'm able to pass that. Okay, let's change the record. It became duplicate. Yeah. So this time I'm able to pass the name, but I'm not able to pass it with the list and tuple because those are containing only the values. But dictionary is something which contains both the key and the value. Now let's say have a take a look at the schema of this data frame. So for the getting the schema, I will just write a simple statement as print schema, and it will give me the schema. So I have two columns, which is ID and name, which types are long and a string value, and they can be nulls. So they are set to true by default. So how does data frame or the Spark understand? So it looks into each and every row of each and every column and assigns the suitable data type to it. So let's say ID by error had in the third record some string value in it. So data frame will automatically change it to a string type data. So but as of now ID columns has both ints. So it is giving a higher type data type which is a long. Now let's say I want to specify the schema as well as the name to the data frame that I am creating. I do not want Databricks to understand anything what it wants because I want to mention that this should be an integer, not a long, and this should be a string type. And there might be other columns I want to specify. I don't want Spark to take that decision for me. So for that, I will deploy a schema to it. And how to create that schema? For that, Spark has a library. So that library comes inside from PySpark.sql.types. So types is one of the libraries which contains all the data types that are supported by Spark. So I am importing all of them. Now let's say I want to create a schema of it. So similarly, how we had string, integer, and varchar chars in SQL, similar data types are supported in PySpark also. But the way to create them is a little bit different. So I will specify calls. Let's say I'm taking this value in a calls variable. So whenever I'm defining the structure of the schema, it should always be enclosed within a struct type. So I say struct type in here, and within that, one by one, I will specify all my columns. So a column becomes a struct field. Now within that, I will pass three arguments. First is the column name. Second is the data type of the column. So first column for me was the ID column. Then for that, I want to keep it as an integer type. Then comes the nullability of it. So whether it can be null or false, false or true. So ID ideally should be always false, means it cannot be null. So I'm passing false value here. So from here to here, it created my first column details. So it took in three variables. First is the ID, the column name, the column type, and whether it can be null or not. Now I will pass in a second value to the column because I have two columns with. I will just simply say a comma here. Let's say I just copy this part. I paste it here. I say the second column name is just name. And this is a string type. And this can be true. I can have that name as for null values. So that works for me. Doesn't matter as of. Okay. Just to have it in a better format, I'm just saying enter here. And just so that Python knows that this is a single value, I'm just putting this slash here. So let's say print the calls. So the column gives me a value something like this. Now, what I will do, I will create the same data frame. Let's say I take the first what we initially took, the tuples, and pass it here. Now, if I do simply this, it will take the original one and pass some random column names, that underscore 1, underscore 2, underscore 3 like that. But now I have created the schema and want to use it. So I will simply give it another argument called schema. And I will say schema is equal to the false value. Now I will pass this. So this time it created a data frame with the correct names and the correct schema also. Let's check the schema. So I say print schema. Hit enter. Okay. Now this time around, ID is not a long. This is an integer. And it cannot be null. So I'm saying this is a false. So this is how we create a data frame manually. Generally, we work with file systems or the files that are coming in from different sources like ADLS, SQL, or anywhere, and that also already has the schema and the columns in different. But at times we need to do our own POCs. So in those cases, creation of a data frame manually is very useful. So this can come in really handy in different cases. So for that, I just went over this. So thank you for this, and I will try to create even more videos on PySpark sessions. So how PySpark works with the different types of data frame, what are the different operations it has. So we'll try to go through them one by one. But thank you for your patience, and let me know if you have any questions in the comments section. Thank you.